Hello friends, I am Chandan. So this is the question from second law of thermodynamics. So try to read this question. Okay, try to understand this question. So what is this question? A reversible engine operates between temperature T1 that is equal to 1000 Kelvin and T2 that is equal to 400 Kelvin. The engine drives a refrigerator which operates between uh, uh, between which operates between T2 that is equal to 400 Kelvin and T3 that is equal to 200 Kelvin. The energy, sorry, uh, the energy transfer to the engine is 200 kilojoule. Okay, that energy transfer to the engine is 200 kilojoule, and the net work output of the combined engine and refrigerator is 300 kilojoule. So the net work output of the combined engine and refrigerator is 300 Kelvin. Okay. Okay. Now the energy transfer to the refrigerator. You have to find out what is the energy transfer to the refrigerator. You have to find out this. What is the energy transfer to the refrigerator in kilojoule? In kilojoule. Now try to understand what is given in the question. So here there is a heat engine that is basically absorb 2000 kilojoule of heat from 2000 Kelvin. So here that is given in this question, the T1 that is equal to 2000 and T2 that is equal to 400 Kelvin. And there is a refrigerator, the lower temperature, higher temperature is 400 Kelvin and lower temperature that is 200 Kelvin. So what is given in this question? So in the heat engine which absorb 2000 kilojoule of heat from 1000 Kelvin temperature and reject heat to 400 Kelvin. And here the work is transferred to the refrigerator. Some amount of water is transferred to the refrigerator, and refrigerator is working in between 200 Kelvin and 400 Kelvin. Basically, refrigerator absorb the heat from 2000 Kelvin, 200 Kelvin, and reject it to 400 Kelvin. In question, the given is that is W engine work produced by the engine minus work absorbed by the refrigerator that is equal to 300 kilojoule. So here what is given in this question? Suppose consider the work produced by the work produced by the engine, and here work is absorbed by the refrigerator that is WR refrigerator refrigerator, that is work uh, engine minus refrigerator that is equal to 300 Kelvin. This is given in this question, that is 300 kilojoule. Okay, so you have to find out what is the W refrigerator. You have to find out that what is the W refrigerator. Okay, so if you want to calculate the efficiency, you know the formula, that is output by input for engine. So for here WE, so for engine this is WE, this is WE. For engine this is WE by 2000. Okay, Q1 WE by this heat. Okay, now that is equal to, you know the formula, that is equal to um, T1 minus T2 by T1. Okay, so from here if you want to calculate the engine, work, that is equal to WE by 2000, that is equal to 1000 minus 400 by 1000. Just put the temperature value. From here you can get the WE. So from here you can get WE value, that is equal to 1200 kilojoule. Okay, So now let's put this value from here. So WE, that is equal to 1200 minus uh, suppose this is WF. So from here you can get WF that is equal to 900 kilojoule. So this will be our answer. Okay, this will be our answer. And if you, this is extra, if you want to calculate the COP, if you want to calculate the COP of the refrigerator, that is equal to Q by W. We know that Q by W. So you know that another formula, that is T2 by T1, T2 by T1 minus T2. Consider this is T2, suppose this is T2 and this is T1. So here the formula will be T2 by T1 minus T2. So Q by W, that is equal to T2. What is the value of T2? That is 200 by 400 minus 200. So basically 200 by 200. Okay. So from here you can calculate that Q, that is equal to W. So here COP will be, as Q is equal to W, the COP will be 1. Okay. COP will be 1. Now if you want to calculate the Q, the amount of Q which is absorbed from the 200 Kelvin temperature, the amount of heat which is absorbed from 200 Kelvin temperature, that is equal to basically WR. What is WR? That is equal to 900 kilojoule. This is the extra. This is the extra. If you want to calculate the amount of heat which is absorbed from the 2000 Kelvin 200 Kelvin temperature. This is basically storage space. Okay, storage space. Okay, now okay, now focus on another question. Okay, so here this is very easy question. Try this, very important question. You can try this easy question. Now let's understand the another question. Read this question carefully. So what is given in this question? Two engines A and B are arranged in series between maximum and minimum temperature, that is 900 Kelvin and 300 Kelvin respectively. So here 900 Kelvin and 300 Kelvin is there. So maximum temperature is 900 Kelvin and minimum temperature, that is 300 Kelvin respectively. Acha. If the work done obtained by engine A is 2 times of the work done by engine B. So here what is given? Work done in engine A, that is equal to 2 times the work done by engine B. Okay. Now if the final heat rejected to the surrounding, if the final heat rejected to the surrounding is 1200 kilojoule. So here if the final heat rejected to the surrounding is 1200 kilojoule, find the efficiency of engine A, efficiency of engine B, overall efficiency, third on overall efficiency, and fourth, that is intermediate temperature. You have to find the intermediate temperature, and fifth, that is heat supplied to the engine. You have to find out these three question. Assume all the cycle are reversible. Assume a reversible engine. Okay, a reversible engine. So what is given in this question? Basically in this question, so here there is a higher temperature, that is 900 Kelvin, and there is a lower temperature, that is 300 Kelvin. Okay, in between there is another temperature. We don't know this temperature. You have to find this temperature. Okay, consider uh, you have to find this temperature. Okay, now uh, consider this is T1 and this is T2, and here this is T3. Okay, So here this is T1, T2 and T3, and in between T1 and T2 there is a heat engine A which absorb Q1 amount of heat and reject Q2 amount of heat and produce work W. And in between T2 and T3 there is another heat engine which absorb Q2 amount of heat and reject Q3 amount of heat and produce work W. And in this question the given that is 1200 kilojoule of heat which is rejected to the 300 Kelvin. Okay, in this question what is given here? Here the if the final heat rejected to the surrounding is 1200 kilojoule, you have to find out uh, the answer of this question. Okay, now another question which is given, that is engine A work done, that is equal to 2 times engine B work done. So consider this is WA and this is WB. Okay, this is A and this is B. So in question this is given, that is WA, that is equal to 2 times WB. So WA means from first law of thermodynamics, that is equal to from first law of thermodynamics, Q1. If you consider this is our system, so Q1 heat is entering to the system and Q2 is outgoing. So Q1 that is equal to W plus Q2. So Q1 that is equal to W plus Q2. From here WA basically. So from here WA that is equal to Q1 minus Q2. Okay, so from here WA that is equal to Q1 minus Q2, and same way 2 into Q2 minus Q3. So this is Q2, so here this is Q2 and this is Q3. Okay, so here you know that uh, Q1 minus Q2 that is equal to T1 minus T2, that is equal to 2 times T2 minus T3. Okay, so T1 temperature is given, that is 900 Kelvin, minus T2 that is equal to 2 into T2 minus 300. Okay, so from here you can find the temperature, intermediate temperature, that is T2, that is equal to 500 Kelvin. Okay, so this is the intermediate temperature. So this is the intermediate temperature. So here intermediate temperature is find out. Okay, what is the intermediate temperature which is find out. Now if you want to calculate the efficiency of engine A, that is equal to, we know that 1 minus TL1 upon TH. So lower temperature minus higher temperature by higher temperature. So 1 minus lower temperature is 500 by higher temperature is 900. So that is equal to 44.44%. Basically this is percent. Okay, so this is another answer. Now if you want to calculate the efficiency of engine B, that is equal to 1 minus TL upon TH. So for engine B the lower temperature is 300 and higher temperature is 500. T2 is 500. So T2 is 500. So here if you want to calculate this will be 40%. Okay, this will be 40%. And if you want to calculate the overall efficiency, the overall efficiency formula is that is equal to 1 minus lower temperature by higher temperature. So 1 minus lower temperature T3 by T1, and if you want to calculate this overall efficiency, so that is equal to 1 minus T3. What is the value of T3? That is 300 by 900. So here T3 300 by 900. So if you calculate this value, this value will be so equal to, you can see that 1 by 3, that is equal to 2 by 3. So this is basically 66.67%. This is the overall efficiency. Okay, if you want to calculate this overall efficiency, the overall efficiency will be 66.67%. Okay, so here the overall efficiency also, so this is find out, this is find out, and overall efficiency also find out. Now, what is heat supplied to the engine B? What is heat supplied to the engine B? Heat supplied to the engine B. So you have to find out the amount of Q2. Okay, so Q3 is given. Q3 that is equal to 200, that is also given. Okay, so efficiency, that is 0. Engine A efficiency, that is 44.44%. Okay, so here if you want to calculate the Q2 value, then you have to so overall efficiency formula, that is equal to W1 by W2 by Q1. Okay, so here if you want to calculate this Q2 value, you have to produce one formula, that is equal to W by Q2. So this is the sorry acha, okay, so so Q efficiency of engine 2, that is 0.4%. Okay, so efficiency here efficiency of engine B, that is basically output, that is W, by input, that is Q2. So from here this is NB, that is given 0.4, that is equal to W. What is W? W, suppose sorry, that is equal to, you can say that 1, so here you can see the 1 minus that is 1 minus 300 by 500. Okay, and W is equal to, so cancel this, efficiency of B. So from here W, that is equal to, you can say that Q2 minus Q3 by Q2, that is equal to 1 minus 3 by 5. Okay, so from here you can find the value Q2 will be here 2000 kilojoule. So this will be our answer. So here this will be our answer. Okay, so this is my handwritten notes. You can download it from the description link. Like, share and subscribe my YouTube channel. Thank you.